Okay, someone's asking, how do you do number 3? So for number 3, the rate of growth, let me erase some stuff. Let me just do this again because I know you came in a little bit late. The rate of growth is just the number on the inside of the parentheses. That's the rate, 1.12. But the percent rate, you always look at whatever's on the inside of the parentheses and you split it up, because really what's going on is that this is 1 plus 0.12. So you always think about, what number did I just add to 1? And that number, 0.12, we turn that into a percentage. So this is 12%. Okay, any other questions? Cool. All right, let's go get into it again. So we're going to basically do a bunch of very similar problems. You're going to be converting from weeks to months, or months to years, or days to months. We're going to be converting things back and forth. So we'll get really used to it by the end of class. Can I get a volunteer, please, to read this example for us?
The function p equals 34,567 times 1.022 t describes the population of a town that is increasing at a rate of 2.2% per year. Transform the function so that it can be used to calculate the percent increase in the town population each decade.
Perfect. Thank you, Chloe. Okay, so this is our function. Let's first, before we transform it, I just want to keep practicing like breaking it down and understanding what each individual part represents. So let's start off with the first number. What does 34,567 represent?
Starting amount.
The starting amount. On a graph, so this is the starting population. On a graph, where would that number be? If I'm graphing it, this is also called the what?
Y-intercept?
Y.
Good, the y-intercept. Okay. What does 1.022 represent?
Rate of growth.
How do we know it's growing?
Because it says that it's increasing.
Good. So it tells me that it's increasing. And then just by looking at the number, how do I know that this is growing?
Because it is more than 1.
More than 1. Good. So remember, when that number is greater than 1, if it's 1 point something, you know that it's growing. What is the percent increase?
2.2.
And of course, it tells us right here. But again, just like we did in the previous example, 1.022 splits into 1 plus 0.022. And then 0.022 is 2.2%. And then finally, what does the t represent?
Years.
Number of years. Good. We know that that's representing years. Well, now we want to turn this into decades. So if you want to know the population in 1 decade, what number would you have to plug into this function?
10.
10. Good. You would have to plug in 10 because 1 decade is 10 years.
Or 10 years.
Exactly. Okay. So any questions on this? Just making sure we understand the basics. Awesome. All right, so now we're going to actually convert it so that it shows us decades. And guess what? We already know the number that's going to get plugged in, because we did the conversion. 1 decade is 10 years. And that's the number that we're going to use in our new function. So let's go ahead and do that. So like I said, we already did this part. 1 decade is 10 years. We're going to plug in 10. And remember, the most important thing is when you figure out the number that you're going to plug in, you also have to figure out the number that's going to bring it back into balance. So I'm going to start with just the original function. I'm going to plug in my 10 and I'm going to do it inside of the parentheses. And when I plug in a 10 on the inside, what number will balance it out on the outside?
1/10.
1/10.
1/10. Good. 1/10. And then to the power of t. Okay, so again, the only reason I'm doing this, I'm not asking for the final population. I'm not asking for, I'm not asking you to plug in something for t. So t is still t. T still represents years. All we're doing is we're rewriting the function. That way I can know the percent of increase per decade. Because now I have 1.022. I'm going to bring that to the power of 10. And I'll get a new number in the parentheses, and that new number is going to be my decade percent of growth. So any questions only just up to this point? I'm not going to plug anything in quite yet. Okay. Well, now I'm going to go into my calculator, 1.022 to the power of 10. 1.022 to the power of 10 is 1.243. So here's my new function. 1.243 to the power of 1/10 t. All right, so it's the same function. I haven't changed anything because remember, we threw it off balance, and then what did we do right away? We popped it back into place, right? So we didn't change anything about the function. The function still works. It's still going to give me the same answer at the end, no matter what I plug in. But now I can see with my eyes how it's going to be each decade rather than each year. So what is the new percent rate of growth? Per decade.
0.243, which is 24.
Okay. Oh, I could barely hear you, Ajira. Can you get a little closer to your mic?
Oh, if we break it apart, it will be 1 plus 0.22, 243, and then 243 in a percent is 24.3%.
Good, beautiful. Very well said. So 0.243 is 24.3%. So every year, let me go back to the original one. Each year, it only grows by 2.2% per year. But over a whole decade, that number increases a lot, right? Because we're measuring a much larger amount of time. So I want to pause there because I already feel like a few of you are understanding it a little bit better. So can you guys tell me either in the chat or you can use your emojis, how do you feel compared to yesterday? Thumbs up, give me, I don't know, there's the little shocked face, the party emoji. Tell me how we're feeling. Okay, cool, I got like 2 thumbs up. I've got like 2 party emojis. I got 1 shocked face.
Party emoji is good, right?
I got 2 shocked face. Yeah, party emoji is good. Party emoji tells me you're feeling great. Good. Juan is also feeling good. Samantha's still a little shocked. So is Bianca. That's okay. By the end of class, my goal is to get at least everybody to a thumbs up. That's the goal. Okay. Let's do another example. Does anyone have any questions on what's on this page right now? Okay. Well, now we're going to use the same exact example, same town, same population, but we're going to transform it so that it highlights the monthly percent increase. Okay. So in this example, I was doing the decades, right? So that's where I got my 10 from. I got 10 because 1 decade is 10 years. Well, now we're going to go with months. So now we got to do the same thing. This time I want to know how much 1 month is. How many years go into 1 month?
1 month,
1 month is how much of a year?
12.
1/12.
1 over 12.
Oh,
1 over 12. I did this with my 7th period yesterday or 8th period yesterday, and I think it kind of helped. So a couple of you who are in my 8th period, Alyssa, Samantha, Chloe, you guys have seen this already, but I didn't do it in the morning. So I just want to show you guys something. Okay, think of a pizza. Think of a pizza that has 12 slices. It's a pretty big pizza. So when I ask you how much of a, wait, how many is that? 1, 2, 3, 4, 5, 6, 7, 8. Okay, something like that. When I ask you how much of a year is 1 month, think of a pizza that's got 12 slices. And if I take 1 month, 1 month is 1 slice. So if I take 1 slice out, how much of it did I take out?
1,
1 out of how many?
12.
How many in total are there?
12.
12 in total, right? So 1 slice is 1 out of 12. So 1 month is 1/12 of a year, right? Because it's 1 slice out of 12. But now think of it like this. What if I ask you how much of a year is 3 months?
3/12.
Good. It would be 3 slices, right? So I have 1, 2, 3 out of 12. But 3 out of 12 simplifies. So what's 3 out of 12?
1/4.
1/4. Good. So 3 months is a fourth of a year. I'll do one more. What would 4 months be?
4 months, 4/12.
4 out of 12, right? And what's 4 out of 12 when you simplify it?
1/3.
1/3. Good. 1/3 of a year. Okay, so always you can think about it with a pizza slice. You can think about it whatever way helps you. When you're finding the conversion rate, let's look at the difference. In this example, I went from years to decades. So I went from small to large. So it was a whole number, right? I had my 10. I plugged in a 10 because I was going from a smaller amount of time to a bigger amount of time. But this time I'm going from years down to months. So the number that I'm going to plug in is a fraction because I'm going from a bigger portion of time to a smaller portion of time. So sometimes you're plugging in a whole number, sometimes you're plugging in a fraction, and it just depends if you're going from small to big or from big to small. But we'll do a few more, like, trust me, the more examples we do, the easier this will get. But that's what we're going to plug in. We're going to plug in 1 over 12. So now P 34,567 times 1.022. I'm just going to keep the original one. Now I'll plug in my 1 over 12. And when my 1 over 12 goes in on the inside, what has to go in on the outside?
12.
12 goes in on the outside. Good. Remember, we always want to balance it back. Okay? When I throw it off balance, we want to push it right back. So how do we feel? Any questions up to this point?
To balance it.
Why do you have to balance it? So the reason we want to balance it is because I don't want to change the actual function, because like, remember, this function is actually representing a real, I mean, it's kind of fake, but it's still a real world example. So if I ask you, what's the population after 10 years? If I ask you that, and I plug in 10, I better get the same answer no matter which equation I use. So if I use my original equation and I plug in a 10, I'll get a number. If I use my new equation and I plug in a 10, I better be getting the same number. Because that's why we throw it back into balance. Because if I don't put that 12, if I don't put it back into balance, then I would get a different answer. So I'm just making sure, by putting that 12 on the outside, I'm just making sure that my function remains equal, that my function stays the same. And so whatever number I plug in, it's not going to change the outcome. Okay. So actually, maybe at the end, we'll come back to this question and we'll see if we do get the same answer. Let's actually test it out later. But for now, I have to simplify my new function. So now I have to do, this is where it gets a little challenging. So here I definitely want to review this part. I have to do 1.022 to the power of 1/12. So when your exponent is a fraction, you have to be very careful on your calculators, because here's the thing with calculators is that they don't know PEMDAS. They don't know what PEMDAS is. They've never heard of it. They never went to school, so they don't know. They don't know what it is. So if I go to my calculator and I go, okay, 1.022, so I put that in, and then I hit my XY button, and then I hit 1 divided by 12. So if I plug all of that into my calculator and I don't put parentheses in there, you know what it's going to do? It's going to do 1.022 to the power of 1. And then it's going to take that number and divide it by 12. And then you're going to get a completely different answer. So the reason we use parentheses is because when you have parentheses on your calculator, it tells your calculator what needs to be grouped together. So now if I do this, 1.022, I'll plug that in. I'll hit my XY button. And I'm going to group together 1 divided by 12. Because now, okay, your calculator will know that the exponent is a fraction. If you don't group them together, it's going to just give you a completely different answer. Okay, so in your calculators, we'll do this together, but we're going to do 1.022, hit the XY button, hit the parentheses button, do 1 over 12, close the parentheses, and then hit enter. So let's do this. And then I see a question in the chat. I'll answer it afterwards. So 1.022, hit your exponent button. Now you got to make your parentheses so that you can group together your fraction. So parentheses, 1 divided by 12. Close the parentheses. And then you have to hit enter because this is not my final answer. I have to hit enter. And there it is. 1.0018. Does anybody want me to do that one more time?
Below the parentheses.
One more time? Okay. So 1.022 to the power So there's xy. Then I right away, I'm going to open parentheses, 1 divided by 12, close the parentheses, and then hit enter. And you can kind of see, like my calculator shows me what I just did. So you can kind of see it over here on the corner, right here. You can see what I did. I did 1.022 xy, parentheses, 1 divided by 12, close parentheses. And then always make sure you hit enter. And here's what we get, 1.0018. So P equals 3, 4, 5, 6, 7 times 1.0018 to the power of 12t. Okay. Now, I want to answer a question. Somebody asked me, how come the 12 wasn't the exponent? Why did I put 1 over 12 inside the parentheses rather than the other way around? And the answer to that is just remember what we did. We're going from years down to months. We're going from a bigger value of time to a smaller value of time. Okay. So the number that we end up with right here is much smaller than the number that we started with, which is this one, right? It's a much smaller number. So the reason we put 1 over 12 on the inside of the parentheses and not the other way around is simply because when you go from a bigger number, when a bigger number of time, so a month, down to a smaller value of time, so when you go from years down to months, that number, the rate of growth is going to get smaller. If you did it the other way around, it would have gotten bigger. So you always want to make sure whatever number you're plugging in matches what you're trying to do. And you'll see the difference, right? In this example, we plugged in 10 on the inside because we were going from years up to decades. So the number got larger. But this time we went from years down to months, so our number got smaller. Okay, so what is my percent, my new percent? Monthly percent. So it's a little bit more challenging, right? We have 1.0018. So that's
if we
0.18.
it will be 0.0018. Then
so what is 0.0018 as a percentage? I think Lauren, I think you said it correctly. Can you say it again?
0.18.
0.18%. Exactly. So we started off with 2.2%. That was our yearly percent of growth. Okay, we started with a pretty small number already. And when we brought it down to months, it got even smaller, 0.18%. All right, now I wanted to test whether we get the same answer. So I do want to do that really quickly because I said I wanted to. So if I want to test, because I want to show you guys that the function, we didn't really change anything about it. We transformed it, but the end result should always stay the same because it's still the same function. So I'm gonna plug in a 10 into the top equation, and then I'm gonna plug a 10 into the bottom, the final function. So we're plugging a 10 into the exponent. So I have to do 1.022 to the power of 10, and then multiply it by 3, 4, 5, 6, 7. So 1.022 to the power of 10 times 3, 4, 5, 6, 7. So I got 42,000. Let me write this down. 42,970 people. Technically 71. So 42,971. So this is after 10 years. Now let's see if we get the same answer with our rewritten function. We should get the same answer. We should. It might be a little bit off because we estimated a little bit and we rounded a little bit, but hopefully we got pretty close. So this time in my exponent, since I have a 12, I have to plug in 120. So I'm plugging in 10 for t, but then I have to multiply it by 12 because there's a 12 in the exponent. So I'm going to plug in 120. So it's 1.0018, 1.0018 to the power of 120 times 3, 4, 5, 6, 7. That's pretty close, 42,893. That is pretty close. So no matter which function you use, since we tried our best to keep it in balance, okay, when you plug in a number, you end up, of course, it's not going to be perfect. It's not going to be perfect because those decimals inside the parentheses, we estimated them a little bit. Technically, it was 1.00182578. Like it was a much longer decimal to start with. So that's why we don't get a perfectly equal answer, but those two numbers are pretty close. That's not bad. So that was kind of to answer, in a long story short, to answer Juan's question about why we need to put it back, why we need to put that 12 on the outside, why do we need to keep it in balance? This is why. It's so that you end up with the same answer no matter which equation you use. Any questions? Okay. All right, so I want you guys to try this on your own. However, I will go pretty slow. I will go step by step. So you don't have to do the whole thing on your own unless you want to. There's a couple people here who I'm sure could do it. So if you feel like you can, then go for it. But for everybody else, we'll go step by step, and I'll let you guys try things on your own as we go. So the first thing I want you guys to know, to ask yourselves first, is what is the percent? First of all, before I finish writing this, is the population growing or decaying?
DK.
Good. We know because it says declining, but we also know because what kind of decimal do we have?
Number less than 1.
Number less than 1, exactly. Okay, so first thing, what is the percent decay? Now don't answer it out loud, don't answer it in the chat. Think of it on your own for a moment. Try it on your own. You can send me your answers privately, and in about 30 seconds, we'll go through it together. And this is the yearly percent. Okay, so the yearly percent decay. Is it 0.9 or is 0.9 something else? Is that my yearly percent decay?
No.
No. What is the 0.9 called when it's just on its own?
Rate.
That's just my rate. Rate of decay. But the percent decay, what do I have to do to this number?
Subtract.
Right, we were subtracting from 1. So 0.9, since I'm decaying, this is 1 minus what?
0.1.
0.1. Good. Okay, because 1 minus 0.1 equals 0.9. The other way you can think about it is try it this way. 1 minus 0.9 gives me 0.1. So that's how I know what is being taken away from 1. So if that is my decimal, what is 0.1 as a percentage?
1%.
How many times do you move that decimal over?
Oh, 10%.
It's 10% because we move this decimal twice to the right. And when you do that, you got to add a 0. So this is 10%. So the percent decay is 10%. Okay? Any questions on that? I know that that's a little bit of a trickier when it's decaying. It's a little trickier. It's a little harder to figure out the percentage. Questions? Okay. So that's my percent decay. Next up, here's my next question. We want to express the population in terms of months. In terms of months. So what is the conversion rate?
1 month equals 1.5 years. No, wait.
Okay, pause. Think it to yourself. But I'll start it with this. 1 month is how many years? Think of it on your own. Think of it to yourself. You can send it privately in the chat. Okay, now you guys let me know. 1 month is how much of a year?
1/12.
1 over 12. It's one slice out of 12 slices that make up 1 year. So so that's my conversion rate. That's the number that I will be plugging in to my function. 1 over 12. So here's the last one. Go ahead on your own. Go ahead and rewrite the function using our conversion. And don't forget that when you throw it off balance, you got to put it back. So rewrite the function. If you want to, you can also go ahead and plug it into your calculator to simplify, but you don't have to do that part. Just write the new function with that new exponent. All right. And let's go ahead and go through it. I'm seeing some great answers in the chat. All right. So my original function, I'll just start with that. Okay. What do I put on the inside?
Our exponent.
Our new exponent. So on the inside goes my 1 over 12. What about on the outside?
12.
12. And my t stays the same, still t. Now, here's the trickier part. This is definitely, we want to make sure we know how to do this. We got to simplify it by plugging that into the calculator. So I'm doing 0.9 to the power of 1 over 12. And do not forget those parentheses. But what I want you guys to do is try it on your own, get an answer, see what you get on your own. So take about 30 seconds to do it on your own. And then when I do it, see if you got the same thing. So test yourself, see if you are using your calculator correctly. Okay, have your answer ready to go on your calculator or write it down. And now I'll show you how what I get when I do it. So 0.9 to the power of 1 over 12. So I'm going to put my parentheses, 1 divided by 12, close parentheses, and hit enter. And I get 0.991. Give me a thumbs up if you got the same thing. Okay, there's some thumbs up. Good. Alyssa got the same thing. Anyone else?
Me as well. I got the same.
You got the same thing? Good. Good, good. Okay. Did anyone get something different and would like me to do it one more time? Tell me in the chat. Anybody? This is something that I need to make sure everybody knows how to do this on their calculator. Does anyone need me to show it one more time? Yeah? Okay.
Show it again.
Yeah, I'll show it one more time. So 0.9 to the power. Now what do I do here?
Parentheses.
Parentheses, right? Open the parentheses. Get your fraction in there, 1 divided by 12, 1 over 12. Close your parentheses. Don't forget to close them. But that's not my answer. I gotta now, what do I have to do?
Click the equals total.
Yeah, hit equals. So there it is. There's my answer. 0.991.
Because the answer that was previously shown is the answer inside the parentheses.
Yeah, yeah. If you don't hit equals, what it's showing me is 1 over 12. Because when you put parentheses in, when you close the parentheses, your calculator just wants to show you what was inside of the parentheses. So you have to hit equals because now you can tell your calculator, I'm done. I want to know my final answer. So that's something that a lot of people forget to do at the end. So just don't forget to hit that equals. 0.991. All right, so here we go. So my new function, 10,000 times 0.991 to the power of 12t. Now it doesn't look much different, right? We went from 0.9 to 0.991. However, remember, originally my percent decay to start with, based on my original function, the percent decay was 10% per year. Well, now I want to know my new percent decay. So this is the last question. What is the monthly percent decay? So we take our new rate, and go ahead, you can use your calculator. What is 1 minus 0.991?
0.09.
0.009, right? There's 2 zeros there.
I didn't know we had to add an extra number for the decimal.
What do you mean?
Is that I put 0.99 instead of like adding the extra.
Oh, I see what you mean. Yeah, the reason I put 3 decimal points, that's a really good point. The reason I did that is because the more decimals you have, the more accurate the answer is. Now, you don't want to go crazy and put like 10 decimal places, but 3, sometimes even 4 decimal places is just going to be a more accurate answer. So that's the only reason I put 0.99991. So my percent decay, what is this number in percent form?
0.9%.
0.9%. So I started with 10% decay, and when I go down to months, it becomes much, much smaller, 0.9%. So again, I'm going to ask again. I'm going to keep asking it today. You guys are going to get sick of this. But tell me with emojis how you're feeling. Party means you're feeling great. Thumbs up means you're feeling pretty good. Shocked face means you're feeling terrible. You're still very confused. And anything else you feel like showing me? What does the laughing emoji mean? I'm confused about that one. Is that a good thing?
Laughing emoji means that this like I would say this topic is pretty
Joy.
It's joyful. Okay. Well, that's good. I can't tell if it's like a sarcastic laugh or like a genuine laugh. So, all right. I feel like I'm seeing more thumbs up. That's good. That's good. That's good. Okay, let's do another one. Any questions on this page before I move on? Cool. Okay. Here's another to try on your own. This time I'm going to put the same questions up, same questions, but I'm going to let you guys try it all on your own from the start to finish. So we won't stop along the way. But what you can do in the chat is check if your answers are correct as you go. So let me start. Let me just write the questions. Okay. So there's my 4 questions. You can write those in your notebook just to keep track of the work that you're doing. But as you go, you can check with me in the chat and let me know, and I can let you know if you're right or wrong. I'll give you guys about 1 more minute. All right, let's go ahead and go through it. So the relationship between the elapsed time in decades since CO2 levels were first measured and the total amount of CO2 in the atmosphere is modeled by the function A of t equals 315 times 1.06 to the power of t. Rewrite the function to express the yearly increase in the amount of CO2 in the atmosphere. All right, so what is the percent growth of CO2 levels per decade?
6%.
6%. Beautiful. Good. 6%. Now we got that from the original function. 1.06, separate it out. We get 1 plus 0.06, so that becomes 6%. Any questions on number 1?
Guillermo math.
Okay. Number 2, what is the conversion rate? So now I'm going from I'm going from decades down to years. So should I have a whole number or a fraction?
Whole number.
I'm getting smaller though.
Oh no, fraction.
Fraction, because I'm going from decades down to years. So this is where we got to think through it, but basically 1 year is how much of a decade?
One
1
tenth.
out of 10.
1/10, 1 out of 10. Good. 1/10 of a decade. Questions on number 2. If you had 10 instead of 1/10, just remember, the easiest way to remember is that if you're going from small amount of time to big amount of time, you should have a whole number. If you're going from a big amount of time to a smaller amount of time, you should have a fraction. So if you're not sure which one you're going to use, always think of it that way. Think about which direction you're going in. So there's my number I'm going to plug in. Here we go. Let's go ahead and rewrite our function. Okay, so I start by plugging in my fraction on the inside, 1/10. What goes on the outside?
Man. I'm sorry.
10.
Okay, 10, good. 10 and then t. Well, now last step is to plug it all into your calculator and then just see what you get on the inside of your parentheses. So this is where we have to make sure in the calculator that you use the parenthesis button, because if you don't use those parentheses, you'll get a completely different thing. So I hope if you didn't have this before, go ahead and take 15, 20 seconds to put it into your calculator and see what you get. And then I'll go over it in 30 seconds. Okay, so plug it in, see what you get. And here we go, 1.06 to the power of 1 over 10. So that's 1.06 to the power, open parentheses, 1 divided by 10, close parentheses, hit equals. And here's what I got, 1.00584. Questions on how I got this number? Does anybody get a different number they want me to double check or show it one more time? Okay, cool. 1.00584. And again, like I know Jaira asked this before, why am I putting so many numbers there? Just because the more you have, the better, the more accurate your answer is. So I just put 5, as long as you got, enough numbers that you can round easily, then you're good to go. So based on this, what is my yearly percent of growth?
if we break it down, 1
Mhm.
plus 0.00584.
Mm-hmm. And
Will it
remember,
be
we're just moving that decimal place, decimal 2 places to the right. So what is my percentage?
0.584?
Good. That's it. So 6% every decade, but 0.584% every year. Questions on any of these numbers? If you got something different and you're not sure why, make sure you ask me. Does anybody have any questions? Why did I add the 1 in the end? So in the end, on the last question, when I'm asking you the percentage, the yearly growth, the percent of yearly growth, remember, this goes to with every single one we've done so far. When you're trying to find the percent, you're always breaking down the rate of growth. So let's go back to the original one. 1.06 was my rate, but the percent is when you split it up, you got 1 plus 0.06. 0.06 as a percentage is 6%. Now I just did the same exact thing with my new rate of growth. 0.00584 becomes 0.584%. It's the same exact process. You look at the number in the parentheses, you split it up, you take that decimal and turn it into a percentage. Okay, any other questions on that? Why do I have to add the year? Where? In what part? Tell me where on this page are you talking about? Okay, so yeah, so 0.00584, it's a tiny, tiny little decimal, right? That's representing the yearly. So yeah, so this is yearly. So this is 0.584% per year. And that makes sense, right? Because we started with decades, we had 6% per decade. When you bring it down all the way to years, it's a much, much smaller number, 0.584. Okay, I've got a couple more in store for you guys. In fact, I've got 3 more in store for you guys. But here's what we're going to do with all 3 of these. With all 3, if you read it carefully, all of them show a yearly rate. Okay, we're talking about years. So for all 3 of these problems, the only thing I need you guys to do is convert it so that it shows us the months. Okay, so before we all begin and get into it, we need to write each function because none of these have the function, the original function. So we're going to have to write the function and then convert the function. And for all 3 of these, what number will I plug into the parentheses?
1 plus 0.9%?
What exponent? So we're going from years to months. So what exponent am I going to have to plug in to each of these?
1.12?
Yeah.
1.12?
Well, not 1.12, 1.5, 1/12.
1/12. Good. So we know we're going to have to plug in the conversion rate is 1 month equals 1/12 of a year. So we'll have to do it to all 3 of them. But before we do that, let's go ahead and write the function. So starting with number 1, because all of these examples so far, they gave us the equation to begin with. Well, now we got to write the equation and then turn it into something else. So with this first one, let's just call all of them, let's call them f of t. What do I write first?
The starting amount.
Starting amount, so 230,600. What goes into my parentheses?
We have to simplify, right? We just can't put the equation.
Right, so I know that I have 0.9%. What do I do with that number?
Turn it into a decimal.
Turn it into a decimal. So what's 0.9 as a decimal?
0.009.
0.009. So be a little careful. Remember, it's going to be a pretty small number. So that's my decimal. Am I adding it to 1 or subtracting it from 1?
Adding.
Adding it. So this is 1 plus 0.009 to the power of t. Questions on that so far? Just want to make sure we understand how to do that. Cool. Now I'm just going to add what's in the parentheses. So this is f of t equals 230,600 times 1.009 to the power of t. So that's my original function. Well, now I have to turn it into monthly percent increase. Right now it's yearly. I got to turn it into monthly. So what am I putting into the parentheses?
The exponent.
My exponent. Good. I didn't give myself a whole lot of room, so I just need to move some stuff over. Okay. Oh, my bad.
Oh, don't tell me it deleted everything.
I bet you it did. Okay. Oh, no, it didn't. Wow. That's a first. Okay. There we go. Okay. So now I'm converting it to monthly. So I've got to turn this into f of t equals 600 times 1.009 to the power of 1 over 12. And what goes on the outside?
12.
12. 12t. So we're going to do this for each of these problems, the same process. Then there's one last step. The last step would be to plug this into your calculator and simplify it. So what I want to do, because there isn't that much time, what I want to do is let's just write the original function for all of them, and then I'll leave you guys to do the conversion on your own. So I'm just going to move on to number 2, and let's just write the original one together. So in this case, what's my starting amount?
40 million.
40 million. So I'm just going to keep it as 40. We'll know that it's in terms of millions. So 40 million. My percentage is my percentage is 35%. How do I write that as a decimal?
0.35.
0.35. Okay. So in my parentheses, that's 1 plus 0.35 to the power of t. But 1 plus 0.35, what does that equal?
1.35.
1.35. Good. So there's my original function. And you guys are going to convert it, use your calculators, and get your final answer. And for the last one, let's go ahead and write the original starting amount. $24,000, good. Percentage as a decimal, what would it be?
0.035.
Good. 0.035. So in the parentheses, I'm adding what's 1 plus 0.035?
1.035.
Good. Cool. There's your starting functions. You're going to convert each of them, plug it into your calculator, and get your final answer. So I'm going to give you guys about 5 minutes to work on that. We'll go over the answers and then we'll be done.
Oh, just write the other equation. You don't have to simplify it or nothing.
Do simplify it. So for example 1, I haven't written the final answer yet because we do want to simplify what's in the parentheses. I'm going to run out of room. Okay, just about one more minute. Okay, for number one, when you plug it into your calculator, what do we get? 0.009 to the power of 1 over 12. What do we get? It's going to be a big decimal. That's okay. What do you get? Did anyone get it?
Which one?
For number one.
Oh, for number one, it is 1.0000746.
Good. So 3 zeros and then 746. That's a big number, but that is correct. Good. Did anyone want me to show that or have any questions on how we got that?
I'm sorry if it's a big number. I remember you saying that we have to see.
No, you did it. No, you did it perfectly right. Good job. Okay, cool. For number two, we're doing the same thing. We're plugging in. What am I plugging in on the inside of the parentheses?
We are going to find the percentage.
So what do I plug in on the inside?
Plug in the inside.
Mm-hmm.
Oh, for number two, I'm sorry. I thought we were still on number one.
Oh, sorry, no.
For number two, we're gonna plug in 1/12.
Good, same exact thing. So we're plugging in 1/12 on the inside and then 12 on the outside. But now in your calculator, you're going to plug that in. And what is 1.35 to the power of 1/12?
1.0253.
1.0253. Good. So that was the answer for number two. And then finally for number three, again, same thing. 1/12 goes on the inside. 12 goes on the outside. And what is 1.035 to the power of 1 over 12?
1.00287.
1.00287. So there we have it. There were the three functions. Does anyone have any questions? Any remaining questions on these three? Look at them thoroughly, see if you have any final remaining questions. Okay, all right. So for homework, don't forget, let me pull it up. There is an assignment due on Friday. I'm sorry that we didn't end up having, I thought we were gonna have a little more time at the end to work on it. We did not, but that's okay. Because I just wanted to make sure we went through the classwork thoroughly. So this assignment is due Friday at midnight. Now, last week I put in a lot of zeros into that grade book. A lot of zeros, a lot of Fs. Don't be that person again. Guys, right now, a matter of fact, right now, if you haven't done the homework yet, right now, take out your phone, go to your calendar on your phone, and set a reminder for yourself. Set a reminder not for Friday, set a reminder for tomorrow at 4 p.m. Tomorrow at 4 p.m., put a new reminder on your phone and say, remember to do your homework. That's how we got to do things, guys. We got to remember things. You can't just keep forgetting, because I have a lot of people who constantly forget, constantly. And they say, no, Ms. Lopez, I'll do it next week. I'll do it next week. And then you keep forgetting. And we got to break that pattern. So remind yourselves on your phone. Maybe if you keep a notebook or if you keep a journal, write it in your journal. If you have Post-it notes or sticky notes on your desk, write it there and place it next to your laptop, somewhere where you look at it every day. Okay, so please just make sure, I don't want to see any Fs in the grade book this week for homework. There shouldn't be any Fs. All right, so with that in mind, we are done, but let me get one last check to see how everyone's feeling about today's topic. So one final emoji in the chat or in the react buttons. Thumbs ups, good. I see a couple parties. Good. Couple people might still feel a little confused, but if you're still feeling a little confused, what's the best thing to do later tonight?
Watch the video.
Rewatch this video, rewatch it on slow motion, take your time with it, take notes on it, do what you can, because I can't teach it again. So now from here on out, it's your responsibility. I pass it on to you. Okay? It's your chance to figure it out for yourself. All right, guys, have a great rest of your day, and I'll see you all tomorrow.
See you tomorrow, Ms. Lopez. Have a
Bye,
nice
everyone. Thank you. Bye, Guillermo.